Calculus, why calculus? Calculus, the study of change. You could find the slope of a line, but calculus you find it all the time. And with this concept alone, we'll cover limits, derivatives, and integrals. We'll find how a function is continuous and measure particle acceleration. We'll find the volume of curves, useful beyond imagination. Calculus, why calculus? Calculus, the study of change. Buckle up for the ride, master calculus with pride. Limit, what is a limit? It's simple for a certain x, that's what y approaches as the distance from x gets smaller. You approach that point from the left and do it again from the right. If both the values equal one another, a true limit is in sight. In some functions, the limit's just the value of a y. If they're not continuous, there are two different sides. If approaches are equal from the left and right, a true limit is in sight. If they are different, the limit is non-existent. Limit, how to write a limit? It's simple. Lim x approaches the value, then the function and the answer. With this skill, further calculus is chill. When you have to solve a limit and are given an equation, first you substitute the x, and if it works, that's a celebration. But if you come to know that your answer is 0, 0, there's still a long way to go. Here's some algebra you should know. The most common method is to factor and cancel the complications. But if it fails and you have a root up top, the conjugate is your salvation. Multiply above and below the line by the root with the opposite sign. If you have a crazy fraction, there is no need to stress. Find the common denominator in the top, divide and cancel to make your problems less. After you choose your strategy, plug in x once more. If only the bottom is 0, then no solution is in store. But if the result is defined, you have reached the finish line. Using graphs and algebra, limits can all be solved, but limits have properties that make solving them less hard. When you have a coefficient within a limit, move it right outside. When you have a function raised to a power, put the whole limit inside. When you add, subtract, divide and multiply, distribute the limit to all functions that are supplied. When the function is a constant, the limit is always that. There are two trig limits where algebra does not work. The properties don't leave a dent. When x approaches 0, sine of x or x is always 1. And 1 minus cos x over x, the limit is always none. Now we know for a fact our knowledge of limits is intact. We've all seen continuous functions, but today we're looking at the opposite. There are three main discontinuities: removable, jump, and infinite. A removable discontinuity is easy to find. There are small holes in the graph, but if that hole were somehow removed, the function would be continuous, back on track. Notice that the limit at that point exists. Factor out the hole and cancel it. There are three main discontinuities: removable, jump, and infinite. Next off you have the jump discontinuity. What is its defining characteristic? The left-hand limit and right-hand limit both approach different values. When you trace the graph with the pencil, think at that point you must lift the utensil. There are three main discontinuities: removable, jump, and infinite. Infinite discontinuities are caused by asymptotes. The function never reaches a certain x value. Instead, it has endless bounds to infinity, which is definitely unfixable. The limit at this value doesn't exist. Infinity is not an answer, please resist. There are three main discontinuities: removable, jump, and infinite. There are three main discontinuities: removable, jump, and infinite. When I trace the graph with a pencil, I don't lift it up. But let's explain this using calculus. Here's a heads up. There are three ways to show that a point is continuous. Three ways to know that you will ace this on the test. If you are proving continuity, you need to prove all three. If you are proving against, disprove one for victory. Step 1, f of x must exist. First check for holes. If you find an unfilled one, stop here, you are done. Next check for asymptotes. If you see any, it's over. If none of the above, move to step 2. There are three ways to show that a point is continuous. Three ways to know that you will ace this on the test. If you are proving continuity, you need to get all three. If you are against, disprove one for victory. Step 2, check to see if the limit at that point exists. Approach from the left and the right. The y values must be alike. If they are not, continuity is out of the question now. Else, go to the final step. There are three ways to show that a point is continuous. Three ways to know that you will ace this on the test. If you are proving continuity, you need to prove all three. If you are proving against, disprove one for victory. Step 3, compare your answers from step 1 and 2. Are they both the same? If they are, great, you have mathematically proven the continuity trait. If it's not, this trait is not in fate. There are three ways to show that a point is continuous. Three ways to know that you will ace this on the test. If you are proving continuity, you need to get all three. If you are proving against, disprove one for victory. Once you know continuous functions, there are ways you gotta use them. Here are the intermediate value and squeeze theorems. If f of x is continuous from an interval a to b, and c is between a and b, then there is at least one f of c between f a and b. If f of x is continuous from an interval a to b, and c is between a and b, then there is at least one f of c between f a and b. If f of x is continuous and it is between functions g and h of x at a certain c. If g of x and h of x have a limit of L, the limit of f of x is L as well. If f of x is continuous and it is between functions g and h of x at a certain c. If g of x and h of x have a limit of L. The limit of f of x is L as well. Once you know continuous functions, there are ways you got